However, it seems pretty easy. Today will also be easy. It gets complicated, but not on this first test. So that's the good part. Do not be overconfident. And if you get it, count your blessings, because others don't. But some people get this just perfectly. Okay? It's like, oh, I got no problem with this. So the first thing is a definition of a permutation. A permutation is a word that you've never used. Okay? It just means that you've arranged some things in a line, in something. Okay? So they call it an ordered arrangement. And so you didn't use any item more than once. And who's first matters. Okay? What? Gosh dang.
You said what? I gotta do something.
This is an advanced class. Okay. So, now, back when I was in high school, if you liked someone else, you made them a mixed tape. Okay? And so, cassette tape. And you recorded things, and then you picked 4 or 5 songs. Okay, so let's pick 5 songs that you like, that are very, very one-word songs. Know any one-word songs? Dive. What's another one-word song? Perfect. Another one-word song. Or 2-word songs. Short songs that don't take us forever to write. I should look this up. Blank space. Is that? Oh, that's right.
Misery business.
What's that?
Misery
Business.
Crawling.
There we go. Crawling. All right. Fantastic. We got 5 songs. Now we want to make a playlist. Okay. So, on Spotify you can buy a playlist, and they'll put it engraved onto a like a wooden cassette thing, and it sell you the display, and it's really cool looking. It's a nice gift idea for Christmas. Okay, just want you to know that if you want to buy a nice gift for someone. All right, ready? Which song should we play first?
Misery business.
Okay, so MB is first. What's the next song we want to play? Crawling. What's the next song we want to play? Perfect. And what's the next one? Dive. And then that leaves us what? Blank space? Okay. Then you're making it go, oh, I don't like that order. I want to put it in a different order. All right, so and then you start thinking, well, how many different possibilities of order are there? So here's the first song on your playlist, right? Your first song. How many different songs can be the first song? All 5 of them? Mm-hmm. And then the second song, how many could be the second song? Mm-mm.
4.
Yeah, because you've already played one of them. So you can't play it again. So only 4 of them. And then the third song, how many can be the third song? 3. And the second song, 2. And the fourth song, and then the 5th song. Make sense? Good enough? So, using the fundamental counting principle, how many different ways are there to make this thing? Haley, using the fundamental counting principle, what do you think? What does the fundamental counting principle say? How many choices are the first one? 5. How many choices is the second one? 4. 5 times 4 times 3 times 2 times 1. I'm going to give you a little hint about probability. If you don't know if you should add or multiply. You might still be wrong. However, you multiply a whole lot more in probability than you add. Okay, so 5 times 4 is 20, times 3 is 60, times 2 is 120. So there's 120 different ways that you make a 5 5-song playlist out of 5 songs. So next one. You have 8 boxes of you bought 8 boxes of cookies. Okay, you gotta put them away in the pantry. So how many ways can the 7 boxes be arranged?
7 boxes.
Think about it.
2 each.
Yes. Very.
But what if I don't want to eat one? I don't want to eat them all.
Oh, I'm just telling you what I do in my life. 1 box is not going in. Actually, I've never put 7 boxes. Okay, so, and let's say they're all, I should say, unique brands of cookies. There's no repeats. So you have 7 different, so it's 7 times 6 times 5 times 4 times 3 times 2 times 1. Which is, I think it's 50-40.
Why? We can't just eat it.
Let me see.
Mess up too much.
And I don't trust myself. Oh, I was right. Okay, easy. What's the next one?
Oh, yes. What?
Are you on the books? Are you doing the books one? Range 5 books on a shelf?
Yes.
What's the answer? We've already done this problem, but we used a playlist. Isn't it 5 times 4 times 3 times 2 times 1? 120. And what's this one? 6. You have 6 performers. So it's 6 times 5 times 4. So it's 720. So those are really, really quite easy things to do. Okay, so there are some terminologies in math that you haven't seen in your life. Okay? One of them is this symbol right here.
Guys, and the exclamation point with a 5.
That's, you know what this is? That's 5!
Yeah.
That's my joke. Gosh, dang it. It's hard. It's hard with a crowd of 2. Okay.
I like it.
All right. So it is called, ready? That thing is called a factorial. Factorial. And it can be used to write the numbers from that number down to 1 multiplied. So 5 factorial is 5 times 4 times 3 times 2 times 1, which is, what do we say, 120? And 4 factorial is 4 times 3 times 2 times 1, which is 24. And 3, you know, you got this, right? 3 times 2 times 1, which is 6, and 2 times 1, which is 2, and 1 times nothing else is equal to 1. And then what do you think? What do you think from your heart of heart is 0 factorial?
0.
0? Guess what?
It's a 1.
It's a 1. All right, it's 1 by definition. Okay, not by math. And the reason why, because many formulas have 0 in the denominator, 0 factorial in the denominator. And so if it was 0, which everybody thinks it should be, you would be divided by 0, you can't do it. So that is the reason. Now, here's what you can do, which is really fun to do. So we have 9 factorial over 6 factorial. That is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Which is over 6 times 5 times 4 times 3 times 2 times 1. Which is fun. Okay? Now, you can type all that in your calculator, or you can realize, hey, wait, those would simplify out. And I'm left with 9 times 8 times 7. Which is, I don't know, about 512 minus something. 9 times 8 times 7. 504. Oops, sorry. 504. Okay? So just little of division problems. Here we go, 16 factorial, 16 times 15 times 14 times 13 times 12 times 11 times 10 times, I'm tired of writing. So I just went down to 9, and instead of writing 9, 8, 7, 6, 5, 4, 3, 2, 1, I'm going to write 9 factorial. And I stopped there because, look there, now my denominator and my numerator have something in common. And so really all I'm interested in is 16 times 15 times 14 times 13 times 12 times 11 times 10. And everybody knows what that is. 16 times 15 times 14 times 13 times 12 times 11 times 10. And of course that is 5, 7, 6, 5, 7, 6, 0, 0. I wish I could teach this class back to back. I memorize that number. Okay? Piece of cake? 576, 576, 00. I can memorize it next time, next year. Okay? So what about this one right here? What's the answer to that one? Without doing any math. Writing anything down.
Not doing any math.
Right, yeah, no, do math, but don't write anything down.
40.
That's it, isn't it?
Yeah.
Yeah, because isn't this one
So there's
40 times 39 factorial over 39 factorial, which is 40. Okay, it's fun teaching this class with people who can do math. All right, so what's 9 factorial over 7 factorial? What's 9 factorial over 7 factorial?
I can't do simple math.
Neither can my other 2 students. That's what he's doing right now. Simple math. No scratch work. No add a line, change the sign. That's all wrong. Okay.
Wait,
72.
Don't
if
be.
you write the wrong answer, can we put
Yes.
an answer?
Yes. Okay.
I just did the 19.
There you go. What's this one? 100 over 100 factorial over 98 factorial. Wouldn't that be 100 times 98? I mean 99. Sorry, 99. Yeah, which is 9900. Okay, so some of these are really simple problems if you understand factorials. Okay, now this is what we're getting to. Do we have notes for this? I mean, vocabulary words for this one? Dang it. Probably look. I can't remember what the official names of all these things is. I want to say the permutation formula, but I'm not sure if I'm correct. Oh. It would help if I went to this right section. The blank blank allows you to determine the number of permutations. The permutation formula, I guess. Okay. All right. So, if you have more than, if you need to make a mixtape of 5 songs, but you have 10 songs to pick from. Okay, now it's going to be much more, right? It's going to be a lot more different ways to do this. Okay, so here's what we got. We got 8 friends. We got Albert. We got Becca. We got Cam. We got Diego. We got Elmer. We got Fred. We have George. And we have Harris. Okay. So we have 8 of your friends. They want to run for the Student Advisory Board. And how many ways can they be elected president, vice president, secretary? So here we go. Here's the president. Here's the vice president. And there's the secretary. Of these 8, how many of them could be president?
8.
Becca can be president? We've never had a woman president.
Yeah.
Yeah. All right. 8. Now, how many can be vice president?
7.
All right. How many can be secretary? 6. So it's 8 times 7 times 6. However, watch this, okay? So in the formula, N is equal to the number of things, and R is the number chosen. So now I'm going to do with the formula up here. So it would be 8 factorial, N factorial, over 8 minus 3 factorial. Because I'm choosing 3 out of the 8. I don't like to use the word choose. I don't like the word choose. Okay, I'm going to... There's 8 people, 8 friends, but only 3 places. So this is equal to 8 factorial over 5 factorial, which is equal to 8 times 7 times 6. Oops, sorry. 8 times 7 times 6, which is what we figured out anyway. Okay, so the formula is kind of nice. So there are 18 horses in the Kentucky Derby. 18 factorial over how many ways can they place first, second, and third? Is this a permutation? Yes, because once a horse places or finishes, it cannot get first and third. I don't think. Okay, so it's going to be 18 minus 3 factorial, which is 18 factorial over 15 factorial, right? And then this 18 times 17 times 16. Which is about 4,896 ways. If 18 horses start the race, there's 4,896 possibilities of them finishing first, second, third. All right, what about the next one? You guys do the next one. You do the next one. You already got it?
You just gave it to me 5 seconds ago. I don't know already.
A corporation has 7 members on its board of directors. Are you using your calculator? So is that 42 times 4 is 168 with a 0? Is that right? I got that wrong? 42 times 20. 840. Well, I multiplied by 4 for some reason. That's weird. Okay. Is that 2? Alright. Piece of cake, right? Not too hard. Okay. Then there's one. Then I wish they wouldn't have put this in here, but they do. It's a little weird, and they call it. We're going to do permutations of duplicate items. Also on the final. This is on the final. This question would be on the final. So, I don't like how they all don't read all that. Okay, let's do the word ANNA. All right, ready girls? Ready? How many ways could we arrange the letters of my sister's name? Okay? How many ways? Well, there's one right there. Tell me another one. Nana. All right. How about N-A-A-N? Nan. How about N-Na? Okay. What's A-A-N-N? Five? I think there's a sixth way.
I mean, you could flip Anna, but it's still Anna. Oh, A-N-A.
Yeah, we don't have A. We don't have N. All right. So, ready? Watch. How many letters are in Anna? 4, right? 4 factorial. However, how do these things repeat? There are 2 A's, right? So we're going to put that in the denominator, 2 A's, and there's 2 N's. And 4 factorial over 2 factorial is, guess what that is? Sorry. No. Okay, so let's figure it out. So 4 times 3 times 2 times 1 over what? 2 times 1 times 2 times 1? Then that equals 6. Okay, so if you're going to use this with a calculator, you might make sure you stack your fractions. It does make it easier. Did you know that calculators have an exclamation point? Almost every single one of them.
Does it mean the same thing?
Yep. And I think on this calculator you have to put the multiplication symbol. Some of them you don't. Boom. A lot of work for a 6 right there. Okay. So here's a test question that will be on this first test. It will also be on your final. So in fact, it's going to be on every test that we take. So if you miss on the final, it's your fault. How many ways can we rearrange Kansas? How many total letters are there? 6 letters, right? How many times does K repeat?
K repeats 1.
All right, so it's 1 factorial, which is 1. I don't really need to put that. A repeats twice, 2 factorial. N is 1, and S is 2. So what's 6 factorial over 2 factorial times 2 factorial? All right.
I got something.
So basically what's in the denominator is how many times each letter repeats. It's kind of a weird thing.
I thought
Right, so that's why we're actually taking them out. This is when you divide by them. That's what you're doing. Is you're actually, hey, an N here and an N here is the same thing as an N here and an N here. So I'm taking that out. Okay, this is why this should be a whole lesson in itself, and it shouldn't be part of this course, but they have it. All right. So, what's 6 factorial? Isn't it 120? And what's 2 factorial times 2 factorial? Isn't that 4? I think so. I think I got 30. All right. Ready? Which one do you want to do? We're going to do one of the last 2. Let's do Tallahassee. Tallahassee. How many letters?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
All right. How many times does the T repeat?
1.
A. L.
Repeat 1, 2 times.
H.
1,
And S.
2.
And E. All right, so now it gets confusing here, right? Did I get them all? Okay, if you do all the letters, then these should add up to 11. 1 plus 3 is 4, 5, 6, 7, 8, 9, 10, 11. Boom. Okay, so I know I got them all. I got all letters. I counted for them all. Now, I want to put this probably in my calculator because I don't know what 11 factorial is right offhand. It's a big number. Okay, so 11 factorial over, what's 3 factorial? 6. This is 6. So this is 6 times 2 times 2 times 2. It's 12, 24, 48. So 11 factorial divided by 11 factorial divided by 48. I got 831600. Okay? And there's permutations. Permutations. The order matters. Now here's how I remember permutations, because there's another one coming next time. Okay? Permutations. Permutations. Place. Place matters. First place, second place, third place. President, whatever. Also, left to right matters. Like if you're putting books on a bookshelf, the order matters. It does. Because they're distinct books. Okay, so that's the end of that lesson. Now we're going to go to lesson 12.1.